Hello, welcome back to lesson 2 of this course, An Introduction to Stata. So last lesson we loaded up Stata, loaded data into Stata, we saved data and did some exercises. In this lesson we're going to be looking at some basic commands, including listing variables, displaying summary information about variables, generating, creating, replacing and renaming variables, labeling variables, applying labels to numeric data, and removing data. So quite a lot to cover, and we're actually going to be using commands in this lesson, so it should be fun. Okay, let's load up Stata first, and then load in the data we saved at the end of last lesson. So lesson underscore 01 underscore your initials. If you aren't confident with this data set, lesson 2, or lesson 02.dta is everything you need, so you can load that in instead. These should be identical, but if you think you made any mistakes last time, you can load up lesson 2. Okay, drag and drop. This should be everything that we had at the end of last lesson. So we have our string variables, the red ones, our labeled numeric variables, the blue ones are numeric variables. We have the data set that we merged in, so date of recruitment, the variable from the merge data set, and we have our underscore merge variable, which we're going to get rid of later. Okay, so on to section 2.1 in the course book. So one of the simplest commands you can use is list, which does as it says. It lists data. So it lists all of the data that you currently have in memory. So all 1,000 observations for all of the variables get listed when you type list. If you have a wide enough screen, this might look a bit better. The reason it's showing blocks for every observation is because I have too many variables to display just in one line. But if you have a wide enough screen, it'll display it much nicer than this. So list just lists things. We can restrict what list shows by specifying the variables that we want to see. So if you wanted to see age and sex only, we type list and then the variables we want, age and sex, and it shows us in a nice neat output all 1,000 observations and their age and their sex, all the way down. You may notice that we have uppercase and lowercase sexes, so uppercase male, uppercase female, lowercase female. These are completely distinct in Stata because Stata is case sensitive. So this is going to come up later. Okay, something to note that my output displayed everything all at once. So yours might not. It depends on your settings. There's a command called set more on or set more off. If we set more on and then repeat the last command, list age and sex, it comes up with this at the bottom. Instead of showing all of the output at once, it shows one screen's worth of output, and then you need to click more to see the next screen, more to see the next screen, more to see the next screen. If you have enough data, this can take an infinity to get through. So there are also these buttons at the top. Break stops you from having to click more, so that it breaks. It allows you to escape the clicking more loop that you're now in. We can do the same thing by clicking Q, so just typing Q into the command bar does the same thing, it breaks it. If you like, so I currently have set more off, so set more off displays SHX all at once. Set more on shows it with the more button. If you want to permanently change the way Stata behaves, you can have set more on permanently. Set more on permanently. And now, whenever I load up Stata, is going to understand that I want more to be on. Alternatively, if you want if you want the more button to disappear entirely forever, it's set more off permanently, and that does the same job in reverse. Okay, that's about it for list. List isn't the most helpful command, but it can be, if you have lots of variables, it can be nice to see two variables presented at the same time rather than going into spreadsheet view or having to reorder variables to put them together so you can see them at the same time. So yeah, list has limited functions. Section 2.2, summarize. Summarize is very useful and we use it all the time. So note the American spelling. Summarize has a Z in Stata. If we tried summarize with an S, it's completely unrecognized. You could create your own command called summarize, which does the job of summarize with a Z, but as it is, we don't have that. So summarize does what it says, gives a summary of one or more variables. If you just type in summarize, then it summarizes every variable in your dataset. You can see var1, that's the ID number, just the numbers 1 to 1,000. It gives us how many observations are non-missing, so that numeric variables, the ones without the full stop. It gives us the mean, standard deviation, minimum and maximum values. For age, 1,000 observations, mean of 126, which instantly should feel wrong because age is measured in years, but we can see there might be a problem here because one of the maximum value of age is 999. That's in fact a missing value. Sometimes people code missing values as 99, 999, or negative numbers. And Stata still treats them as numbers until we tell them that those numbers should in fact be missing. Sex, 0 observations. This is because sex is a string and you can't summarize a string. Summarize only works for numbers because you can't have a mean or a standard deviation for a string, or indeed a minimum or maximum. Height, weight have some missing values we can see, and strangely enough, the mean values of height and weight are very similar. When you measure in centimeters and pounds, apparently they become very similar. And it keeps going for all the variables. Like with list, we can specify which variables we want. So summarize actually isn't too bad if you do it for everything when you don't have that many variables. But if you have hundreds of variables, you more than likely just want to summarize ones that you're interested in. Like most commands, summarize is often abbreviated, shortened. I use sum, but you can actually use su if you don't want to type the full extra letter of an M, just to make your life easier. So if we wanted to summarize age and sex again, we would type sum, age, sex, and it just summarizes age and sex. We can also add an option in to give more detail for what we're looking at. So let's just focus on age, sum age, and use the option detail. So we have a comma because whatever comes after a comma is an option. You only ever need one comma no matter how many options that you put in, but you need the comma before specifying any options. And the option detail, again, does what it says. It gives more detail to the summary. So instead of just having observations, mean, standard deviation, minimum, maximum, we have percentiles. So 50th percentile, that's the median. So the median age is 53. For smallest values, for largest values, again, 999 looks pretty wrong. Sum of WGT, that's sum of the weights. We're not going to deal with weights in this course, but you can weight observations in Stata so they have different weights, different relative values when you're looking at every observation. We also get the mean, standard deviation, but also the variance, that's the square of the standard deviation, the skewness and kurtosis, which is a measure of how skewed the dataset is when you look at it in a histogram. Okay, that's about it for sum. It's fairly self-explanatory. If you want more help, sometimes when you help, you come up, you can have to select which type of thing you want. We look at functions in one of the later lessons, which are slightly different from commands, but we actually want help in the summarize command, and it can tell you lots of interesting information about summarize. Okay, section 2.3, tabulate. So tabulate, to me, this it would actually mean table, but there is a different function, different command, in Stata called table that creates tables. But it's like creating a frequency table for either one variable or for a pair of variables, and we'll go through both. So tabulate, used with categorical variables. So these are variables that have different levels or different groups. You can use it with a continuous variable, but it will produce a meaningless result. So if we try to tabulate age, for instance, it's going to give us a frequency table of every age, and there's a lot of different ages. This isn't actually too bad because they're in years. If we did it to the nearest day, then this would just be 1,000 lines long, this particular table. So we use tabulate with categorical variables. So let's tabulate hair color, because that's not how you spell tabulate. Let's tabulate hair color, and it gives us a nice frequency table showing us the number of observations where the hair color is black, so 199, 20%, blonde, 288, 29%, and the final column is cumulative percentage. So this is 20.29 for the first, for black, then 49.64, that's 20.29 plus 29.36. 79.61 is all three of those together. So it's just the running total of the percentages for each category. So yeah, we see the frequency, we see the percentages. We also see that only 981 observations are recorded in this tabulation. This is because missing values, so a missing value in a string is just a blank bit of string, the missing values would take this total up to 1,000. So there must be 19 missing values. We can see those if we tabulate hair color, comma, missing. So we can put the option of missing in, and the missing string, so the missing values of hair color, are then presented at the top of this table, so you can see them. Right, a couple of things to note. Tabulate, often shortened to tab, and something I don't think I've mentioned before, we don't need to write out the full variable name in order to capture the variables. Hair is unique. There are no other variables in this dataset that start with the word hair. So if we tab hair, we get the same output as if we typed in tabulate hair color. If you don't feel particularly confident doing that, if you type in the shorter form of the variable you're looking for and press tab, it'll auto-complete the variable for you. So you don't need to type out everything, you can press tab and have it magically appear. If you press tab and it's not a unique variable that you're specifying, it can bring up an option, drop-down list for which variables are available. And it's slightly annoying that it's showing it down here. There are only the two options, but it would be nicer if it was spaced up so we could be sure. Okay, so one-way frequency tables is just the command tabulate followed by a single variable, sometimes with the option missing if you want missing values. Two-way frequency tables, so tabulate hair color and current smoker, so I'm using the tab there to write in the variable faster and to stop me from mistyping. So we put two variables in and it brings up a two-way frequency table. So this shows us every row is observations that have black hair, so blonde hair, brown hair, so rows are hair color, columns are smoking status. So this is the current smoker variable, where 1 equals yes, 2 equals no, and this information comes in fact from the variable label. So you can see current smoker has the label smoking status 1 equals yes, 2 equals no. That's what's filled in there. Hair color doesn't have a label, so what's filled in here is just the variable name hair underscore color. But the columns show for 1 people who smoke and for 2 people who don't smoke. So we can read across. The number of people with black hair who smoke is 67. Number of people with black hair who don't smoke is 130, and it totals 197. This is in fact slightly different to the one-way frequency table, and that's because of missing values again. So let's do the same command and put the missing values in. Missing. There we go. So we have 67 people with black hair who smoke, 130 with black hair who don't smoke, and 2 people with black hair for which the value of smoking status is missing, so we don't know whether they smoke or not. And that adds up to the 199 people with black hair that we see in the one-way frequency table. What we don't have in this two-way frequency table is the percentage of people, the percentages. And this is because you could either have the percentages going across the rows, so the percentage of people with black hair who smoke, the percentage who don't smoke, the people who for which it's missing. We could either have it going across the rows, or we could have it going down the columns, where the percentage of people who smoke, who have black hair, percentage of people who smoke, who have blonde hair, etc. So you can specify whether you want the row percentages or whether you want the column percentages. You can also specify that you want both, but I wouldn't recommend it in general. So this is another option. So it just every option comes after the comma. You only need the one comma. So if you want the row percentages, we just add the word row into the options bit of the command, and it brings up underneath the number of observations in each group, the percentage of observations across the row. So you can see the percentages across the row add up to 100%. So black hair, we know that 33.67% of people smoke, and 65.33% of people don't smoke, and 1.01% of people we don't know whether they smoke or not, adding up to 100%. If we want to do the same thing for the column, we type in column, and the percentages change to being the percentage of people who smoke with missing hair color, with black hair color, blonde hair color, etc., adding up to 100% down the columns. If in fact you want both, you can do it, but it gets into a bit of a mess. You can still clearly see that which ones are rows and which ones are columns, because you look for the row of percentages that add up to 100%. So we know this row is the row percentages, meaning this number or this row must be the column percentages. But it tends to be better to either stick with rows or stick with columns. Okay. Numeric or labeled numeric variables like accommodation. Let's just take a quick look. Accommodation is the only labeled numeric variable in our dataset presently. Merge is also a labeled numeric variable, but this is the only one that's we've created that is labeled numeric. So when we tab it or tabulate it, we see, in fact, the labels rather than the underlying numbers. So you can see accommodation 1 is own, 2 is mortgage, 3 is rent. So we could work out that this is actually a 1, this is actually a 2, and this is actually a 3. But we might want to make sure of that. So we can tabulate accommodation and have another option, no label, which removes the label that is applied to accommodation. So instead of seeing own, rent, and mortgage, we see the underlying numbers 1, 2, and 3. This can be pretty useful because when you start having really quite long and difficult labels applied to variables, and you want to use if statements, we cover those in the next lesson, to say do this command, but only do it for people who own their house, then you actually don't need the word own, you need to specify the number 1. We will come on to that next lesson, but this makes it easier to see which numbers you need to specify, because the words are just labels applied to the variable. Stata doesn't understand anything about those words. Okay, the other thing we can do with this is we could force these labels to have the numbers as a prefix. So force each of these to have 1 own, 2 mortgage, 3 rent. And we can make Stata do that, but that's not until section 2.8. Okay, let's move on. Section 2.4, generating variables. So if you want to create a new variable in Stata, the command is generate. We then have a new variable name, and the new variable name needs to follow the same rules that we had in the last lesson. Has to start with a character, or a underscore. Can't have any other symbols, so can't have exclamation marks or equal signs or anything. Just an underscore, and it's case sensitive. But and it has to be unique. So a new variable name needs to be just that, a new variable name. If we try to generate a variable called height, Stata would throw an error and say, no, it already exists. What you mean is replace. Which is part of the efforts to stop us overwriting data already in Stata. So generate new variable name, and then an equal sign, and then some expression. The expressions that you give Stata can be as simple as you like. So a new variable could be twice the variable height, so you get the height times 2. Or it could be weight times 15, or it could be weight plus 1, minus 1, it could be weight squared. Anything that you can think of could go here. There is no upper limit on how complex a command or an expression could be. I once did an insanely long command, which I copied out into Word because it was so long, and it was 10 lines of a normal Word page long. So yeah, it can be as complicated as you like. It's just, it gets then more confusing, so it's less certain whether it's actually right. So let's do a few examples. Let's suppose we want to generate the average blood pressure. So we have systolic blood pressure and we have diastolic blood pressure. I don't think there's any clinical use in creating an average of those two, but let's pretend there is. So generate average underscore BP is equal to systolic BP. I'm using tab again to make sure I don't mess these up. Systolic underscore BP plus diastolic underscore BP, and then we want it to be divided by 2, so / divides in Lublin Stata, divided by 2. Stata gives us an output for this if there are missing values, and it just says 73 missing values generated. That's fine. If we summarize systolic BP, diastolic BP, and we may as well summarize average BP now. Then systolic BP has 25 missing values, diastolic blood pressure has 49 missing values, so the fact we have 73 missing values here isn't terribly surprising. There's more than 73 missing values in the two variables we use to create average blood pressure. So the missing values don't get used in expressions. In general, they are always kept as missing. Stata knows how to deal with them. We can also see the mean for average BP is pretty much halfway between these two. Standard deviation is 10.6, fine, and it's got minimum and maximum values, so that's all looking about right. The reason I use brackets is because Stata follows the BODMAS rules. So that's brackets first, then orders, that's your to the power 2, so squared, to the power 3 cubed, to the power half, square root. So brackets, then orders, then division, multiplication, addition, and subtraction. We need the brackets here because otherwise the division comes first, and this would have become systolic blood pressure plus diastolic blood pressure over 2, which wouldn't be right. So if in doubt, use brackets to make it look how it needs to in order to be comfortable. It's creating exactly what you want it to. The spaces that I put in here don't matter. I'll quickly drop this. So dropping variables is something that we'll do in the last section of this lesson, because it's a bit less safe because you're actually removing variables. But just to show you quickly, the spaces that I put in between each bit of this command don't matter at all. They're there. If you want to put spaces in to make it look clearer, which is what I do, that's fine. If you don't want the spaces in because you think it looks clearer without putting the spaces in, don't put the spaces in. It means to Stata it's exactly the same thing. And we can summarize just to be sure. And this line look identical to me. So yeah, spaces don't matter in your expressions, apart from to make sure that you know what everything is doing and how it looks. Okay, so let's add another variable. We're going to generate a second ID variable equal to, and here the expression, instead of using an existing variable, we're using _n, which in Stata language means the row number when you go into the spreadsheet view. So _n is 1, 2, 3, 4, 5, 6, all the way down to 1000. So it's in fact going to be exactly the same variable as this var1 variable, but we're creating it rather than having it already exist. There's no output because there's no missing values. It's just the row number, so let's scroll across. ID2 generated, and it's 1, 2, 3, 4, 5, 6, etc. all the way up to 1000. Good, that's what we wanted. So generate, useful, incredibly useful command, but the things to bear in mind, command, new variable name is equal to some expression. As we go through the course, we're going to be generating and replacing variables, and we're going to use it, hopefully lots of expressions. With practice, it should become clear what you need to type in order to get the outcome that you want. That said, move on to section 2.5, replacing variables. So once a variable exists, you can't generate that variable again with the same name. This is why I had to drop the average BP variable we just created in order to create it again. It's part of Stata's efforts to prevent you from overwriting data. So instead of using the command generate, we can use the command replace to replace any existing variable with a new expression. So the syntax is exactly the same as generate, which means I could have just copied this from above, but there we go. So replace our existing variable name, so anything that already exists, is equal to some expression. We can even include the existing variable that we're replacing in the expression. That doesn't matter, that's fine. If we wanted to replace height with meters instead of centimeters, which is in fact our next example, then we can do that. So let's replace height, which is currently in centimeters, with height divided by 100 to make sure that height is now in meters, because there are 100 centimeters in a meter. We click enter, and it says there are 957 real changes made. So whenever you replace data inside Stata, it tells you how many changes it's made to the data. In this case, it's not 1,000. Let's just quickly, I meant to type some there. Summarize height, there are only 957 non-missing observations, so every one of those changed. And they changed down to the meters, which is what we wanted. Okay, we've also noticed weight is summarize weight. Weight is in pounds, so the mean is 169 pounds. And we would like this to be in kilograms. So we can divide weight in pounds by 2.20462, which is the conversion to go from pounds to kilograms. There are 2.2 pounds in every kilogram. Click enter. It tells us 944 real changes were made. And we know there's only 944 observations in weight. The rest of them are missing, so that's fine. Now that we have height and weight in meters and kilograms, and you can see the labels haven't changed, we'll need to do that manually in a bit. But now we have meters and kilograms, we can create body mass index. Body mass index is equal to weight in kilograms divided by height squared. And we get height squared by putting in this capit, I think it's called, shift 6, which is the notation used to imply height to the power of 2. So height squared, height times height. And we get 95 missing values generated. Fine, let's just take a quick look and summarize height, weight, and BMI. Firstly, let's check that. We probably should have checked this first, but check the minimum and maximum values of height and weight and the means to make sure they're what we were expecting. So height, 1.68 meters, that seems perfectly acceptable for a mean of height. Range of 1.5 meters-ish to 1.9 meters-ish, that's very tall, but that's perfectly plausible. Weight, mean of 77-ish kilograms, seems fine. Minimum of 43.5, maximum of 112. For 1,000 people, that seems fine also. We also have 43 missing values here, 56 missing values here, and 95 missing values in BMI. So we've used both height and weight, so we're happy that 95 missing values isn't too many. If we add both those up, that's a maximum number of missing values I would expect in BMI. And we get a mean of 26.98, which is almost 27, which is about right for BMI. Minimum of 17 and 17.4, maximum of 37.3, which again seems plausible. So whenever we generate and replace variables, it can definitely make sense to check that what we've done has done exactly as we expected. Here we're just dividing by 100 or dividing by 2.2, but weight divided by height squared, we might have got the order of things wrong, so it's always good to check. Okay, that's everything on replacing variables. Again, we're going to go through many more generations and replacements as we go through. So on to section 2.6, renaming variables. So renaming variables, fortunately, is quite simple. We use the rename command, where we type in rename, then the old variable name, and then the new variable name, which is pretty much everything in rename. The only thing you can't do is rename a variable that doesn't exist. So you always have to specify an existing variable name, and you can't rename a variable to something that isn't allowed. So you need to start a new variable with a character, not a number, and you can't use symbols other than an underscore. And it has to be unique, so you can't name it something that already exists. So we have two variables here called var1 and var13. This is in fact what Stata does when you load in data where the variable doesn't have a name. There's no header for that particular column. You might not have any headers, in which case the variables will just be named var1, var2, var3, var4, all the way up to however many variables you have. So var1, var2, etc. isn't very useful. Let's rename them. var1 is in fact ID, so rename var1 ID. Nothing is displayed in the results window, but if you look at the top, it's no longer this variable ID, no longer called var1, called ID. And let's do the same for var13, and let's just call that marathon, because the label description says ran a marathon in past year. So rename var13 marathon. If you make a mistake, a mistype here, just rename it again. So there's no undo button, you can't go back to it being called var13, but without typing, rename marathon var13, and then rename var13 marathon. You just have to use the rename for whatever you mistype in. Okay, renaming is pretty simple and fine. Section 2.7, labeling variables. Labeling a variable is also pretty simple, but the command is a two-word command. So it's label a variable and then a variable name. So that's an existing variable. And then in quotation marks, we have some label that you want to give it. So any label that you want to give it. In the last lesson, we went through the what you can put in here. I'm pretty sure it's anything up to about 80 characters. So these are just strings. You can use as many different symbols as you like. You can use numbers, you can use anything. It's not a variable name, it's just a string attached to the variable for it to be more informative. So plenty of examples up here. Hair color doesn't have a label, nor does average BP or BMI, or indeed ID2. So let's label them all. So label variable, we're going to start with hair color, and I'm going to tab through to make sure that I don't mistype. Hair color doesn't need much more of a description than hair color. It's arguable that we don't need to label that at all because it's pretty descriptive already. But average BP could mean many things. So it's the average of systolic and diastolic blood pressure, and it's measured in mmHg, is in fact millimeters of mercury, because blood pressure is measured with a sphygmomanometer, and it's the number of millimeters of mercury that go up a particular dial. Label variable, this time ID2. This is the ID number, and it's the second ID number, which is now redundant because we in fact have an ID number. Now that we've named it properly, we know what it is. So this is not useful anymore, so we'll be dropping that later. And finally, label variable BMI. This is useful because not everyone knows what the acronym BMI stands for, and it could mean many things. Body mass index, and that's measured in kilograms per meter squared, which we know because we in fact divided weight in kilograms by height squared, height in meters squared. Okay, so now we can look at top right, and all of these variables have labels now, which also means when we tabulated hair color earlier, it just came up with hair underscore color. Now we do it, and it comes up with the label hair color. So that's a bit nicer. Okay, if you want to remove a label, so let's remove the label for ID2 because we'll be deleting that soon anyway. You just type in label variable and then the variable name without any actual label, and it removes everything. So yeah, if you want to get rid of it, label variable, the variable name, and nothing else. Yes, we changed these variables, height and weight, we changed them to be in meters and to be in kilograms. The label doesn't reflect that, so let's update them because that is actually quite confusing. Label variable height in meters, and label variable weight is weight in, I was going to write meters there, weight in kilograms. There we go, so that's updated, and now those numbers, those labels are correct. For these, we're overwriting metadata. So these are data that is applied to a variable. Stata doesn't mind if we overwrite these. We don't need any additional options to overwrite variable labels, which is a bit strange because Stata is very concerned about overwriting data for almost everything else. Anyway, section 2.8, labeling values. So labeling variables changes what appears up here and changes what appears in the results bit of commands. Labeling values applies a label to a numeric variable to be more informative. So this is more involved and is a two-stage command. Every command that we've seen so far has been just one command does one thing. This is a two-stage command. We need to define the label that we're going to apply to a variable, and then we're going to apply it. The point of doing that, or the reason why it's useful to have a two-stage command here, is we might have a label such as yes, no, 0 equals no, 1 equals yes, or vice versa, and we want to apply it to a huge number of variables because we've got lots of yes, no questions in our data set. So by being able to create a label and then apply it to as many variables as we like, we can save time and effort. So numeric labeled numeric variables are blue, and we're going to create some more blue variables by, let's see, we're going to give a label to marathon, and we're going to give a label to current smoker to make these more informative. Okay, so the syntax. First thing we need to do is define a label. So we define a label, we give it a name, and this needs to be a unique label name. The label names are completely distinct from the variable names. So it doesn't matter if you have a label name that is the same as any of these variable names. Little confusing, and why often people who create labels with something like an underscore label at the end, just to be clear that it is a label you're creating. It's not necessary, but some people do it. We then have a series of numbers followed by a string. So, first number. These don't need to be in order, and they don't need to start at 0 or 1. They can start wherever you like. So the first number has some meaning. So if we were creating a variable where 0 is no, a label, sorry, where 0 is no and 1 is yes, the first number would be 0, and that what we put in the quotation marks is no. And we're then creating the 1 means yes, so we put in 1 to mean yes. We then continue up until I think 6,000. 1,000 or 65,500 numbers with paired meanings. It depends which version of Stata you have, but 1,000 should really be enough. Okay, once we've defined the label, we then apply it. So we say label the values of list of variable names. So this can be as long as necessary in order to apply the label to as many variables as you like. And then the final thing we give it is the label name that we just created using the label define command. Okay, that's a lot to take in, so let's do a couple of examples. We're first going to do define a label for the marathon variable. So marathon label. 0 means no, 1 means yes. Stata doesn't give an output here. It just, if it doesn't give you an error, then it did something. In this case, hopefully created the label, marathon label, with the meanings 0 is no, 1 is yes. And then we're going to label the values of marathon, the variable marathon, with the label marathon label. Again, Stata doesn't give an output. It doesn't give an error either, so we can assume it did something. The way that we see what it did is just have a look. So before, marathon was a list of zeros and ones. Technically, it still is. No's are zeros, ones are yeses. But it's more informative now. Instead of being 0 and 1, where 0 could mean yes or no, 1 could mean yes or no, it could mean anything. The variable is called marathon. It could mean the number of marathons done in the last 10 days or the last 12 years. We don't know. But now it's more informative because we've labelled those values. 0 means no, 1 means yes. We're now going to define the label for smoker or current smoker. So we're going to call it smoker label, where 0 means yes, and 1 means yes, and 2 means no. So similar to this label here, except instead of 0 and 1, it's 1 and 2. No error messages, we can assume it did something. We're then going to label the values of current smoker. Let's tab through. Current smoker with the label we just created in the define command, smoker label. Go. No error message, we can assume it did something, and when we look, yes. So current smoker is no longer numeric, it's labeled numeric, where the 2's are no's and the 1's are yeses. If we wanted to, we could have replaced the values of current smoker so that the 2's became 0's, and we could have used the same label for both because it's just 0's are no's, 1's are yeses. And I think we do something similar to that in the next lesson. Okay, so labels, we can also use tab to check tab, marathon, and current smoker. We can use tab to check that it's done as we asked. So it's not showing us the numbers anymore, it's showing us the labels that we put over the numbers. And if we were to do the same thing, but with the no label option, we can see what it actually is. So 0's and 1's and 1's and 2's. Okay, we can also use the num label command. So this method here of tabulating without the no label command and tabulating with the no label command can be a quick way of working out what each of these numbers, actually is. So we wouldn't know 1 equals yes, 2 equals no, apart from it's said here in the caption. That's quite helpful. Unless we put in the no label command. This can get very difficult to cope with if you have a large number of different labelled numbers. So if you have the numbers 1 to 50 all labelled with a different meaning, it'd be very difficult to work out which one is which from doing this particular method. If we use the num label command, this adds numbers to each of the labels, so it's clear that 0's will be no, 1's equals yeses. Let's do it and then see exactly what it does. So num label, and then we want to specify a number of labels that we have, and then we have the option add. So you can both add number prefixes and you can take them away using the same command, using the options add and remove. Again, it doesn't show us anything that it's done, but let's get rid of that. If we tabulate marathon and smoker, a current smoker again, we can see that what Stata has done with the num label command is add in the number that is the value that corresponds to the label. So the 0's were no's, the 1's are yeses for ran a marathon in the past year, and for smoking status, 1's are yeses, 2's are no's. So instead of having to use tabbing and then tabbing without the labels, you can see them all at the same time. This may or may not be useful for you, and you may want to just do it once and then remove them. That's fine. Instead of having the add option, we use the remove option. Tab it again, and the numbers are removed. Okay, so num label is quite helpful and can be useful when you're trying to work out what each number represents. What we haven't seen so far is how to find out which labels you have in your data set. We do this with the label dir, short for directory, which shows us we have these 4 labels currently in our data set. The smoker label, which we just created, the marathon label, again, we just created it, the accommodation label, which is the label that applies to the variable accommodation. I created this earlier for the data set. And we also have the merge label, which was created when we merged in the date of recruitment variable, and it applies to the _merge variable. Okay, so those are the labels in memory, but just showing the name of it isn't necessarily helpful. So we can use the command label list. Notice that all these label commands are label and then another word after that. And this shows us for every label we have in memory what each number corresponds to. So we have all of that information there. If you want to drop labels, remove them entirely from the dataset so they're no longer available and they're not applied to the data anymore, we can use the label drop command, and that removes the variable from memory. So we've dropped the merge label and it no longer exists. That also means when we look at the data, the merge variable is no longer labeled numeric. It is simply numeric, 1s and 3s. Okay, if we want to modify labels, so supposing we got something wrong, we can use the label define command again. So it's label define, and then the variable, the label that we want to change, and let's say we want to add a label to it, or label add a number and label pair to it. So smoker label currently doesn't have anything in 0. Zeros don't mean anything, they would just appear as zeros in our data. But suppose we want to add the label, added label, we can use the add option with label define, and you can see that this has added the number label pair 0 and added label to the smoker label. Yep, and if we want to modify, that's a slightly different command. Label define again, the name of the existing label, and then the number that we want to change. So we no longer want 0 to mean added label, we want 0 to mean modified label. And then instead of having the option add, it already exists. So we need a different option to modify, and that is modify. Label list. We can see the smoker label has 0 as modified label rather than added label now. So it's been modified. Good. Finally, we can remove number label pairs as well. So again, it's the smoker define command with the name of the existing label, and it's a modify again, but this time we're defining the value of 0 to be a blank string, and this means to Stata remove this value entirely. We no longer want this value to mean anything. Label list, and it's gone entirely. So that is, I think, everything that you hopefully want to know about labels. They're very useful in general. If you want to make your data as meaningful as possible, labels are very useful for any categorical variable. Even binary variables where the zeros always mean no's, ones always mean yeses, or zeros is not having the outcome, ones is having the outcome. It's very useful to put in labels on top of those, because other people using the data set might not know that piece of information, or they might not appreciate having to check the variable label to see. There's also no guarantee that someone hasn't flipped zeros and ones in the data, but then not updated the variable labels, in which case everything is now wrong. So it's very useful to apply labels to data to make it clearer what's going on. Okay, section 2.9. I think the last section before the exercises. Yes, last section before the exercises, removing data. So I've already done an example of removing a variable, but let's go through it again. Variables to be removed. So Stata's remove data, please. Command is drop, and this removes both variables and it can remove observations. I'm not going to go through removing observations until the next lesson because this requires using the if or in restriction statements, which is complicated and is worth an extra lesson. So we're just going to go through removing variables, and it's drop, and then whichever variables you want to be removed. In this case, we want to remove merge in ID2 because the merge variable doesn't tell us anything that's useful anymore, and the ID2 variable is identical to the ID variable, so it's redundant, we can get rid of it. Worth stressing, there's no undo button. If you drop something accidentally, there's no getting it back. So if you are working off a do file, it's not a problem, you just redo the commands up to the point where you made a mistake. If you're working in the command window, then you're going to have to reset. So go all the way back up to when you loaded in the dataset, repeat all the commands that you just put in, and then you'll be back to where you started before you accidentally dropped something that you weren't supposed to drop. That's why do files are so good. Okay, the Stata won't give an error message. Won't give a message here to tell you what's been dropped or why. It assumed you know what you're doing. The only reason it would give an error is if you type in a variable that doesn't exist. So if you type in something that doesn't exist, it'll tell you the variable's not found. Which incidentally it does for most commands. If you type in a variable that doesn't exist, it will tell you this doesn't exist, what are you trying to do? So that is everything that we're going to change and save. So let's save our data again. Lesson 02sh.dta. Place. So let's save the data because we'll be using this data set again in the next lesson. There we go, saved. Let's just have a quick check. If you don't set your directory, then just typing in this will save it to wherever your current directory is. Yes. Let's try that again, but it's saving to the proper location. There we go. And lesson 02 underscore your initials has appeared, hopefully. Good. Right, let's just do a bit more dropping of data. So this is saved. We can do what we want to the dataset now without worrying about what's going to happen or worrying about what we're going to do in the next lesson. So the keep command is what we're going to talk about now. Drop removes the specified variables. Keep keeps the specified variables and drops literally everything else. So if you want to keep ID, age, sex, height, and weight, we can either type in keep and then specify age, sex, height, weight, or we can use the Stata shorthand, which is when you're specifying a group of variables, you can specify the first one, put a dash, and then specify the last one. So keep ID dash weight means keep the variables ID to weight, which is all of these variables here. Click enter, and suddenly we've lost all of the other data. It's just gone. There's no getting it back without reloading a data set. So keep is powerful, but make sure you're fully aware of what it's doing because you'll just lose all of the data that you don't specify. Okay, another quick trick. If you want to remove all of your variables, you can drop and then specify underscore all, which is the Stata shorthand for all variables, and they disappear. What this doesn't do is get rid of your labels, because drop only refers to variables. If you wanted to drop all of the labels, you would need to use label drop instead. I'm actually uncertain about what's going to happen here. Label list. Okay, so underscore all works there too. So if you wanted to remove all of your labels at once, you can label drop underscore all. If you want to remove all of your variables at once, you can use drop underscore all, and it removes both. There might still be some things in memory though, and we're going to talk about some other things later about what might be still left in memory and what you can use. So clear is actually Stata's preferred method for, I want to reset Stata. I want to just make it completely blank and then do something else. So clear removes everything. This is in fact the option that we put on when we open a data set and there's something already in memory. We use comma clear because we're telling Stata clear everything, then load in the data set that we want. Okay, so that is everything for this lesson. Have a go at 2.10, the exercise. It's slightly more involved than the first set of exercises, so it may take slightly longer, and I'll be back in a bit with the answers. Okay. Hello, welcome back. I hope you enjoyed those exercises. Let's go through the answers. So 2.10 exercise, question 1. Load in the exercise _01 _ your initials.dta dataset from the first exercise. If you're not confident, feel free to use the exercise _02 dataset instead. Let's have a look. Exercise _01, my initials. There we go. Let's have a quick look. Okay, you've got ID, var3, that's going to need renaming. We've got 2 labeled variables. Okay, height, weight, good. Question 2, list the values of age and height together. So we're going to use the list command followed by age and height. List age, height. Gives us a list of 1,500 observations. Some of these values are -1. That's another missing value. We'll have to deal with that later. Okay. Question 3. Summarize the dataset, then summarize height in detail. So summarize, shortened to sum. Summarize everything. Let's have a look. ID, 1,500 observations. Age, 1,371. That's in months. So these numbers are a lot bigger than they would be for years. Variable 3, that's sex, and that's 0 because it's a string. We've got height, some -1 values, deal with them later. Weight, hair colour, everything else it looks fine. Okay, and then, what was it? Summarize height in detail. Sum height, and we use the detail option. Options can also be shortened to a unique option within the command that you're looking at, only if the command allows it, but in this case detail can be shortened to D, so sum height D for detail, and again we can see those smallest values are -1. Okay, check to see if anything looks wrong here. Yep, -1 is definitely not a height. Okay, question 4, tabulate hair colour and find out how many people have red hair. So tab hair colour. And we have black, brown, blonde, grey and red. Blonde is spelt wrong. We'll be dealing with that in a later lesson. Found out how many people have red hair. 141, 9.65%. Question 5. Tabulate hair colour and accommodation to find out and find out what percentage of people with black hair rent. Okay, so tabulate again. This time hair colour and accommodation. We have black, brown, blonde, grey, own, mortgage, rent, and we're looking for the percentage of people with black hair that rent. So we're going to want to put percentages on this, and we want to know how many people with black hair rent, so we're going to put the row percentages on. So row as an option, and ideally we would also add the missing option, because some people with missing accommodation have black hair. So the actual number who rent, or actual percentage of people with black hair who rent, is 46.3. However, if you didn't include the missing values, that's fine. Sometimes we include them, sometimes we don't. So in this case, 48.36% or 46.3%, they're both acceptable as the percentage of people with black hair who rent. Question 6. Tabulate hair colour and accommodation to find out what percentage of people who own their home have grey hair. Okay, so this time we want percentage of people who own their home, so we're looking in the columns. There we are. So we now see the percentage of people who have black, brown, blonde, grey and red hair. We want the percentage of people who own who have grey hair, and it's 12%. See, 12% of the people, 12.06% of the people who own their house have grey hair. Again, we might want to include missing values here, or we might not. Either is acceptable for these questions, and the answer with missing values would be 11.73%. The number of decimal places doesn't really matter. Stata shows them to 2 decimal places. If you rounded, that's also fine. Question 7. Add number prefixes to hair colour and accommodation labels, and tabulate hair colour and accommodation again to check it worked. Okay, so this is the num label command. So we want to num label, and we want it for the hair color and accommodation labels. The part of the question is you'll need to list the labels to find out which labels you'll need in order to add the number prefixes, because if I type num label, I then don't know what the labels are that I need to type in. So let's list them. There's only two, hair color and accommodation. In fairness, I could have guessed that, since those are in fact the same label names as variable names. So num label, hair color and accommodation, and I clearly forgot to add the add option. There we are. Stata's error messages do tend to be reasonably helpful. Oftentimes this particular code isn't helpful, but oftentimes there is a useful bit of information to find out what part of the command isn't right. Okay, so I should have added number prefixes to all of these labels, so good. Modifying the hair color label, so blonde is spelled correctly. Okay, let's take a quick look. Hair color is definitely labeled numeric. We know that, it's blue, and we've been fiddling with the labels, so we know that. So the value of blonde is 3. We know that both from looking at it, and now we've applied the number label to it. We know which label, which number label pair needs fixing. So we want to label define, because when we're changing or creating labels, it's always label define. The label name is hair color, and we are just changing the option 3, which presently is blonde without the E. We want it to be blonde with the E, and we want to tell Stata that we're modifying it. So modify, and then if we tab again, we can see it's now got the correct version of blonde, so it's spelled correctly. Part B of this question is see if you can spot a new problem with it. If so, see if you can fix it. So the problem is, when we changed the label, we didn't put a number prefix in. Now the number prefix that num label adds is literally just it's just a string. So it's the number followed by a full stop followed by a space. This isn't special in any way. It's not an option. It literally changes the label in the same way that we're doing here. So what we could do to fix it is we could modify this again, but add in the number first. So 3 dot space blonde. And then when we tab hair color and accommodation, it looks like it should do. 3 dot blonde. Okay, another way we could have fixed it is, let's just go back to blonde. Another way to fix it would be to, again, num label hair, num label hair color with the option add. What this does is it tells us there are value labels that are only partially num labeled. Stata's making up words again. Specify option detail for a list of these value labels. Specify option force to modify value labels anyway. So based on the output we got there, we could either add the option detail, let's see what that does. And it brings up label name, hair color. These are the values, these are the labels. So we can see that we haven't specified blonde correctly. But we can specify the option force to modify the label values anyway. Okay, let's try that. We don't need detail anymore, we're going to force it. Doesn't come up with anything, but let's tab hair color again, and then we're back to 3 dot space blonde. So either of those solutions will work. If you got there, well done. Question 9, convert age to years and weight to kilograms. And it gives you the information that 1 stone is 6.35 kilograms. Okay, so age, presently in months. So we want to use the replace command because age already exists. And we want to replace age with age, but divided by 12 for the 12 months in the year. It tells us that there's 1,371 real changes. And we'll just take a quick look at age. There are 1,371 numbers, the rest of them are missing. So that's good, that matches. And the mean age is around 50 years, 49.61 years. So with a minimum of 20, maximum of 80. So that looks right. Good. And we also want to convert weight to kilograms. So again, weight exists, so we're going to replace it. Replace weight equals weight. And this time we're going from stones to kilograms. 1 stone is 6.35 kilograms. So for every weight, we should have 6.35 kilograms. So we're multiplying up. And let's take another look at weight. So 1,491 changes, 1,491 observations. Good. And the mean weight is now 76.48 kilograms. That looks fine. And a range of 42 to 134 kilograms, which again looks pretty plausible. So good. We're satisfied with that. Question 10. Generate body mass index, then give it an informative label. Summarize the variable to check if it looks about right. If not, think about why they might be wrong. Okay, so this is the same generate command that we used in the lesson. So we're going to generate BMI is equal to height in meters divided by weight in kilograms divided by height in meters squared. 9 missing values generated. That seems like a small number. Summarize height, weight, BMI. And it's a small number because there's every value of height exists, and there's 9 values of weight that are missing, so there are 9 values of BMI that are missing. But let's take a quick look at them. BMI, mean of 30, that is plausible, that seems a bit high. Minimum of 16.9, maximum 107.7. That's impossible. You can't have a BMI that big. Now, thinking about why that might be wrong, it's going to be, there are some values of height that are -1. When Stata doesn't know they're missing, so Stata just thinks that's -1, fine, I'll use it in the calculation. Weight divided by height squared, if the values are -1, -1 squared is 1, because the minus number times a minus number is positive. So this is their weight divided by a height of 1 meter, which is very, very low for BMI, for height, and so you get these very high values of BMI. So those are wrong, and we'll be fixing those in the next lesson. For now, though, question 11, create a label for income and apply it to the variable using these number meaning pairs, then check if it worked. And it gives us a list. So this is a label for, that we need to define. In this case, income. You can either call it income, income label, or anything of your choice. I'm going to call it income. So label define income, where the value of 1 means less than 18,000. The value of 2 means 18,000 to 30,000, like that. Value 3 is equal to 30,000 to 50,000, and value 4 is equal to 50,000 plus. Click enter. No error messages popped up, so it looks like that has been accepted. So the label's been created. Nothing has happened to the variable yet. So we've created a label for income here, but it's not applied to it yet. We still need to do that. And the way we do that is we want to label the values of a particular variable, income, with the label income. When you use the same label name as the variable name, it's both simple to do this step of the command, because you just need the same word twice, but it can also look confusing. So this is why people sometimes define the labels with an underscore label underscore L or something on it like that. Personally, I like having the same variable and label names, but that's just me. So income now, instead of being 1, 2, 3, 4, is numeric labeled variable where everything looks more informative. You can also tabulate it to check, and it looks good. So yeah, and doesn't look like I have any spelling errors, which is quite nice. Good. So question 10, didn't quite answer all of that. Summarize, give it an informative variable label. So going back to question 10 quickly, we're going to label the variable BMI. We've created it, but if we look down here, BMI doesn't have an informative label. So label variable BMI, body mass index, kilograms per meter squared. Apologies, should have read the question better. Okay, moving on to question 12. Rename variable 3, variable 14 to something more informative using the variable labels as a guide. Okay, so variable 3, sex. So rename var 3. Let's just call that sex. So the name is sex, the label of sex. Makes sense. Variable 14. Let's rename that too. And let's rename it to rename var 14. Let's rename it to smoking status. This is what's called current smoker in the lesson data set, but we're going to call it smoking status here. If you call it current smoker, fine. If you call it anything else, smoking, smoker, whatever, as long as you know what it means and it refers to smoking status, perfectly acceptable. Okay, question 13. Remove the merge variable. Okay, if we're removing variables, we're using the drop command, and all we need to do is specify which variable we want, underscore merge. Not found. Okay, so the merge variable doesn't exist in my dataset because when we went through the exercises in the first lesson, I used the merge command with the no generate option, so it didn't create the merge variable. However, you may or may not have done that, so you may have had the merge variable to drop, so that will have dropped it for you. Okay, last question is just save the modified dataset, calling it exercise underscore 02 underscore your initials. So my working directory is currently not in the place that I need it to be, so I'm actually going to do a save as command here. Data files, and it's exercise underscore 02 underscore sh. And this is the dataset that we're going to be carrying forward to the next set of exercises. So save, and good. Okay, I hope you enjoyed that, and see you again for the next lesson.